Hello everyone, my name is Jishin Deng. Currently I'm taking advanced mechatronics. So today I'm going to talk my final project, hip exoskeleton modeling. Agenda. First, I'm going to talk about the parts and the transfer function of the hip exoskeleton. Then I'm going to talk about two most popular actuators, cross direct drive, QDD, and series elastic actuator, SEA. Then I'm going to show you guys the results of simulation of bandwidth and backdrivability we did on those two actuators, QDD and SEA. At the end, I'm going to tell you guys what I've learned in this semester, in this class. Hip exoskeleton is a robotic device that provided rehabilitation for human performance during normal walking or load walking. It contains two gear, two motor, two control board, a waist frame, and two tight brace. It's ruled by the transfer function. And also when it also can apply the torque force that help people working with less energy. QDD is a device that contains a sensor. When the sensor notices that people are going to working, it will transfer the information or signals to the motor that applied on the people's hip, and the motor will apply the torque force that help people walking. There are two parameters are very important to determine which actuator is better. The one is bandwidth. Bandwidth is the measurement for the actuator, how fast that it responds. For example, we have a sensor. When people walking, we notice that a sensor have to transfer the muscle signal or something like this, to the motor to help people walking. So we notice that the faster the signal transferred, the more reliable of the devices is. And another most important parameter is backdrivability. Basically, backdrivability is a level of easiness of the transformation from the output axis to input axis of the movement. We noticed that the large backdrivability will contain low resistance forces. So which means when the devices is off, we have large backdrivability number, the resistance of working without any support will be easier. And also here is the transfer function, how to derive the backdrivability. So here we're comparing the SEA and QDD. We notice that SEA actuator have the low bandwidth and medium backdrivability. Also, QDD actuator have the high backdrivability, which means low resistance forces, and also with high bandwidth, meaning that the signal transfers fast, and also with the lowest mass, which means is light wearable. We can see the QDD and the SEA backdrivability comparison. So the only thing we worried in this plot is the Y value. We compare the QDD and SEA at the first peak. So we can see that QDD is less than SEA. That means the resistance force is less than the SEA. Another diagram we see here is QDD and SEA bandwidth comparison, which means how the signal, which devices transfer the fast signal. So it's obviously QDD transfer the signal frequency with 154.3 frequency. But SEA, the frequency only can be 8.15, which is a lot difference. So and also I learned, I think in this semester, I learned a lot. I learned the transfer function application. I mean, I have learned transfer function in 411, but it's all theoretically. Like I know the PID controller, PI controller, and something like this, but I don't know how to apply those controllers into the reality situation. But in this class, I know it's like very helpful classes. And that at the beginning of the class, we learned the Arduino application. We're doing a lot of labs with Arduino. It's kind of the introduction of the mechatronics. It's very helpful. And also in this class lecture, I learned a lot of mechatronic devices, such as how the actuator works, how the controller works, and also how the decoder works. It's very helpful. All right, that's all.